All right, welcome to worksheet 25, part 2. Last video, we talked about half of the work 25, where we try to find the volume of solid. Here, we're going to do pretty much the same thing, except now you notice here, we're going to have a formula right here. You notice that this is done in dy. So I'm going to highlight that here, dy. And the function is in terms of y. So this is when we start rotating about y-axis. So when you slice it like that, so you see a circle, the cross section will give you circles. And then if you look at the height of each slice, that's in terms of y, right? So that's delta y. So if your object is oriented this way, then we're gonna kind of have to do it in terms of dy. So you're gonna write in terms of y, and then your function is gonna be in terms of y, and then you're gonna have dy instead of dx as your variable, okay? And then the lower limit and the upper limit of the integration will be like the lowest point of the y and the highest point of y, right? So the method is exactly the same, and this is going to be slightly weird because we are not doing everything in terms of y. So let's see how it works. How do we know if you're setting up? So now we have choice of dx or dy. How do you know which one to use when we do the washer method, the disk method? When you rotate region about x-axis, the thickness of the disk is going to be dx. That's why integral is dx. That's what we did in part 1. In this part, we're going to do rotate about y-axis, and then it's going to be dy. It's going to be the thickness of the disk, and then integral is going to be in terms of dy. So let's look at example 4 here and see what happens. Consider the region bounded by y is equal to x cubed plus 8. So it's a cubic function. Goes like this, right? Generally speaking. And then I have 9 minus x plus 1 squared. Again, this is square, so quadratic function. There's negative in front of x squared term. So it's the parabola going backwards. So this must be y is equal to 9 minus x plus 1 squared. And this is y is equal to x cubed minus 8. And also set, so this bounded by here and by x-axis. I'm sorry, y-axis. So this is my y-axis. So I have graph goes like this, graph that goes like this, and then y-axis. Okay, so they're talking about this region that is bounded. Like this part they didn't shade it because it's not bounded by, it's like open up here. This part is not bounded by. So when they say bounded by, it has to be completely enclosed in all sides, right? So this part doesn't apply, this part doesn't apply, this part doesn't apply. Find the volume of solid generated by revolving the region. So I'm going to call this R. About y-axis. So this is slightly different. So instead of rotating it this way, I'm going to rotate it this way, right? So I'm going to imagine everything is rotated. So like this point is going to be rotated this way, right? Like this point is going to be rotated this way. So this will give you like a big circle. This is going to be like small circle. If you go down here, it's going to be small circle. And then this part is like not really there, right? So the solid we're going to see is something like this, right? It's going to be like rotated like this way, rotated this way, rotated this way, so on and so forth. So here the cross section is a circle this way. And then if you, let me use red here to, if I'm looking at a disk, a thickness you can see is this much, which is the y direction, right? It's up and down. So this is going to be delta y, which is going to translate to dy. So when I set up the integral to find the volume, I'm going to do it dy, right? That means everything has to be in terms of y. So kind of have to solve it in terms of y. So here my function has to be written. So, okay, so y x cubed is equal to y plus 8. That means x is equal to cube root of y plus 8. And then also, for the other function, x plus 1 squared is equal to, I'm moving here, 9 minus y. So x plus 1 is equal to radical 9 minus y. It's plus minus actually. X is equal to negative 1 plus minus radical 9 minus y, right? So which part is it? Is it the plus part or the minus part? So let's look at this point right here when y is equal to 0. plug in y0 is, so just to check when y is equal to 0, x is equal to -1 plus minus radical 9. So radical -1 plus minus 3, so it could be -4, or it could be -1 plus 3, 2. So it could be -4, it could be 2. Here we're looking for this part of the graph, so we're looking at the part where it's plus part. Minus part will be the other side of the graph. So here I'm going to say x is equal to -1 plus radical 9 minus y. Okay, so that's the function on the bottom. So I have this function, not bottom, but function that's representing the parabola here. So I have this function, and then I have this function, right? So I'm looking at the solid here. I'm looking at the lowest value of y is -8, and it goes to +8. So let's look at like one of the, let me draw another disk like right here. So again, I'm looking for surface area of this part, which is circle, and that's determined by this function, which is this function, right? So pi r squared times dy, I have that. However, if you look at the circle on the top, cross-section on the top, this slice, the radius is determined by this function parabola, which is that, right? So I'm going to have two different integrals. So I'm going to go from -8 to 0. So that's the bottom part, which is determined by this function, which is that. So I'm going to have to say pi 3 radical y plus 8, the whole thing squared, plus 0 to 8. That's the top part. Well, cross-section is determined by this function, which is that. So I'm going to say pi -1 plus radical 9 minus y, the whole thing square, dy. Here, this is probably going to be hard to actually calculate the actual answer. So here, I'm going to just have a setup, find the value. I'm going to make that into just set up the equation, set up the integrals. Okay, so this will be my final answer. All right, so this one I had to be super careful. Let's look at the next question here. Example 5. Consider the region bounded by y is equal to 1/3. Okay, 1/3 x. There's no x squared, so it's a straight line. And then x is equal to y squared. Okay, so it's not y is equal to x squared, but it's x is equal to y squared. So it's quadratic in terms of this way, or I can think of this as y is equal to radical x. So I can look at it either way. So let's look at the graph of the first one. Y is equal to 1/3 x. So start from 0, 0. Slope is 1/3. So 3 over 1, 3 over 1, 3 over 1 goes like this. Y is equal to 1/3 x. Graph goes like this, right? They say first quadrant, so I'm just going to look at this part. The next one is x is equal to y squared, so I can look at this as y if you want to. It's like this way. So let's graph that in red. So radical, where do they exactly meet? Here, I kind of knew it was going to be 9, 3. This is where they meet. Y is equal to radical x. How do I know that more precisely? I can again set that equal to each other. So 1/3 x is equal to radical x. Square both sides, 1 over 9. X is equal to x squared. When you solve it, you get 0 and 9. So I know where they meet. So we're talking about this region here. Just region R. So this kind of tiny region right there. Find the volume of solid generating by revolving this region bounded by this region about y-axis. So this is completely bounded, right? So this part doesn't count because it's not bounded completely. So it has to be completely enclosed. About y-axis, okay, so they want to rotate this about y-axis. So everything is going to be rotated like about y-axis. So it's going to be like this way. This point is going to be like this way. This point is going to be just here. Sometimes it's hard to imagine, so just pick like some sample points and kind of imagine that round being rotated. So it's like this, right? Here we're this far from the y-axis, so we're going to be on the other side, right? So it's going to look something like this. So it's going to be like a bowl, but like this inside is empty, right? So I'm gonna highlight rotate it about y-axis. So that means I know it's gonna be done dy, because when I look at the cross section here, I have to take the cross section perpendicular to y-axis. Then you'll see a cross-sectional surface that goes like this and then goes like this, right? There's a lot of graph here, but inside is empty. So I'll look at this cross-section, so it's gonna be dy. So I'll do something dy. Again, y starts from 0. The highest point of y is 3, so that part I can do that. Oops, 0 here, and then 3 here. So when I see this thing here, washer, outside the circle is determined by a straight line. Inside circle, maybe I should have used red, is determined by this, right? That's function. So outside function is determined by the straight line, which is that. Again, I have to have everything in terms of y, so I can't really put 1/3 x. So I have to convert that. So I'm going to do some calculation. I need to change that into x is equal to 3y. Okay, so pi 3y squared. So that's the area of the big circle, the blue one, and then I have to subtract the one in the red, which is determined by y is equal to radical x. Or again, I can't really write a radical x because this is have to be in terms of y. So I'm going to use here y squared. So minus pi y squared. That's pi 0 to 3, 9y squared minus y fourth dy. So that means it's going to be pi 9 1/3 y cubed 3 to 0 minus 1/5 y fifth 3 to 0. When you calculate this out, you get 162 pi over 5. Okay. The next question is follow the volume of the solid by same thing, but they want to rotate now about x-axis. Maybe I should highlight that, x-axis. Okay, so in my head, okay, this is going to be done in dx. And also, let me first draw the graph then. Same graph, 9, 3 goes here, so I get a straight line like this. And then I get the radical x like this. So y is equal to radical x, and then this is y is equal to 1/3 x. So this is region R. They want to rotate it about x-axis this time. So again, I'm going to look at x-axis here, so I'm going to rotate about this one. So take some sample point, this point is going to go around the x-axis, so it's going to go like this, right? Again, this is from like 3 steps away from x-axis. So when you go around, it's going to be that 3 steps away from x-axis the other side. So it's going to be like here, 1, 2, 3. I can have another sample point, maybe here 4, right? So 4 is, it's going to rotate about x-axis. Like here is 2 steps away, so it'd be 2 steps away. This is 6, not 4, sorry. It's like this, so it's going to be like that, right? So again, it's just like a cone, but like inside is empty, right? So again, if I cut it this way, you're going to see 2 circles, cross sections. One is like this one, and then the outer cross section is like this one, right? So the outer one is determined by the radical x, and the inner circle is determined by 1/3 x. And I know it's going to be dx because I'm rotating it about x-axis. So dx, smallest x value is 0. The biggest x value is 9. So I'm going to go from 0 to 9. Again, if I'm looking at a random cross section, the area of the surface area of this is outer circle minus the inner circle. So outer circle is radical x. So that's going to be pi radical x squared minus pi. The small circle is this one, the blue one, 1/3 y. Oh, 1/3 x. 1/3 x squared. X minus 1/9 x squared dx. And when you calculate this out, 27 pi over 2 is what you're going to get. All right. And let's look at the next one here. This one has a little extra twist. Find the volume V of wedding band obtaining by rotating the region between this function x squared plus 2. Again, this is a parabola that goes like this. This is 4 minus x squared. Parabola goes like this. And about horizontal line y is equal to -3. Okay, that's going to change everything. Before it was just rotate about x-axis or y-axis, but now it says y is equal to -3. What does that mean? Okay, so first of all, this is horizontal line. When y is -3, so y is -3 is here. So this line goes through this. So let me draw that. This is rotational x. So things are going to be rotated around this. So things are going to change a little bit. So let's draw this one, x squared plus 2. So it's a parabola up by 2. So here it goes up by 2, right? So when x is 2 is 2 squared plus, so that's 6. Well, it doesn't. So it's going to be like, okay, so that's f of x. G of x is 4 minus x squared. So when x is 0 is 4, and then just facing back that way. So when it's 1, that's 3. So I'm going to make it like, so when I plug in 1 here, that's 4 minus 1, that's 3. So it goes like this way. It goes like this way, right? Again, to precisely calculate where they meet, where f of n and g of x intersect, where x squared plus 2 is 4 minus x squared. 2x squared is equal to 2x squared is equal to 1. So x is plus minus 1. It's okay. So here and here, we kind of knew that, but just to make sure verify that. So this is region R. Again, like this part, like everything has to be completely enclosed. So this part is not enclosed by these two functions, and so on and so forth. Now I'm going to rotate it about this. So let's see. First of all, let me try to imagine how this is going to look like. So I have a sample point here. I'm rotating here, so it's pretty far. 1, 2, 3, 4, 5, 6 steps. So it's going to rotate like this way. So it's going to be pretty big picture. So I'm going to have something like here, right? So it's going to be pretty big object solid here, right? So this part is going to be rotated like this. So you're going to get something here. So it's kind of like a wedding ring or a ring, except, yeah, and with the hollow inside, right? So how do I set this up? So I'm going to do integral. So again, this one is basically like x-axis, right? So when you cut this cross section, that's when you're going to see circle this way, circle this way. So my thickness is dx. So even though it didn't say x-axis, any horizontal line is basically like x-axis. So it's going to be dx. The biggest x value is -1. I'm sorry, yeah, -1. The smallest x value is 1. We can notice that this is even function, so I can go from 0 to 1 and double it, right? So from here to here is exactly the same as here to here. So I can go 0. Instead of going from -1 to 1, I'm going to go 0 to 1 and then double that. If I look at a cross section, let's say this cross section, the outer circle is going to be the red function is going to be the outer one, and then the blue one is going to be the inner one. So outer one is going to be the red function, which is g of x. If I should have labeled that, that's g of x, 4 minus x squared. So now, so I was going to write just 4 minus x. I'm just going to write 4 minus x squared, but that's just the distance from here to here, right? So like at this, like at this point, when I plug in 0 for x, this is just 4. So that's this distance. But when you look at the cross section, like my circle is huge. So what's the radius of my circle? Well, this is 4 here, and then we have to have 1, 2, 3 extra because it's this, right? So if you look at the radius of the big circle, if I imagine, that's like 3 plus 4, right? So for any red graph, like here, when you look at this cross section, what's the radius? Well, when x is 1, is 3 is the radius normally, but then, well, I'm not rotating, I'm rotating here, so this radius is going to be 6, right? So this is going to be 3 plus 4. So 3 plus whatever the red function is going to be the radius. So I'm going to do this. Instead of writing it like this, I'm going to write 3 plus 4 minus x squared. That's the radius. The whole thing squared. I'm going to put the pi outside already, right? Minus, how about the small one? Kind of same way. So I'll probably need more space here. Small one is x plus 2. So again, each radius is going to be bigger by 3, right? Like here is 1, but then the radius for the small circle is actually 4 because 1 plus 3. So kind of does the same thing. 3 plus x squared plus 2, the whole thing squared. Wow. So 2 pi 0 to 1. So that's going to be 7 minus x squared squared minus 5 plus x squared squared dx. So it gets a little bit more complicated if I'm rotating it something else than x-axis. I have to here, I'm just looking at the graph, I have to add 3 because radius gets larger. There are times where radius gets smaller, then I just have to subtract that much, right? So this is how I'll set it up. And here you get 96 pi over 3 will be final answer. And that's it for this section.